to one example. First, this is the water filling system. What happened here? First, when the water level is low, that means the switch is open, microcontroller will activate the water pump WP1, and then they will fill the tank until it level is high, which limit switch is closed, and then they will deactivate the water pump. The system will keep track the running time of the pump LED will lead of the running time exceed 50 hours. Indicate the pump require maintenance. That means every 50 hours of working, the water pump need to be maintained. So you need to do some maintenance calibration and so on. And then the running time is stored in the Eeprom such that the value is still intact even the power losses. And then the switch one you use to reset the stored running time in Eeprom. Okay, what happened here? Every 50 hours you need to do the maintenance for water pump. And then we need to store the running time in Eeprom such that the value still, let's say, for example, you have run this one for 30 hours, suddenly break up. So you will keep the data in 30 hours and then blackout, after blackout you turn on back. So the turning on time is after, let's say, 5 hours of the blackout. So what happened? Is it the time still 35 or 30? So we need to use 30 because the function is 30 hours. So where you want to get this 30 hours? You store in the Eeprom lah, so that you can extract even though after blackout. And then the switch just to reset lah. Let's say for example 30 hours the water pump broken, so you replace the new one and then you reset whatever value in Eeprom so that you can keep track the new time. Okay, this is the example coding. First you have Eeprom library, and then this one variable declaration. This one you have two input. One is switch, and then the other one is limit switch in the tank. And then you have two output. First you have motor for the relay and then one for LED. Alright, this is the coding there. If digital read 8 is low and the pump status equal to 0, so T1 equal to milli, that's just to measure time, and then digital write 9 high, they akan turn on the water pump so that it fill the water. Else, if digital read high and the pump status is 1, they will measure another time and then they will deactivate the water pump. That means when the pump is on and then it reach the maximum water pump, the maximum limit, so they will turn off the pump. Okay. Runtime T2 minus T1. So they want to measure how long the motor have been turning on the water pump there. Total runtime, they store at the library of 0. Total runtime equal to total runtime plus runtime. So they will update the new total runtime. Let's say for example this one you have already 2 hours and then they add another this one 1 hour, so it's now 3 hours. So we'll keep store in Eeprom. Where's Eeprom lab address? They will store it at the 0. Okay, if total runtime more than 180,000, that means 50 hours, they will turn on the LED just to show it's more than 50 hours. If digital rhyme 6 low, that means the switch the push button switch low, they will reset the value in Eeprom. Okay, so you know how it functions lah, so that we can keep, let's say after, like I said before, after 30 hours suddenly shut down, electricity problem, then after 5 hours they will turn on back. So they want to keep this 30 hours so that they know when it will limit 50 hours to do the maintenance of the water pump. So this is how Eeprom function. That's all. Thank you. Bye bye.